Welcome back. This is Ink, and in today's problem, we want to find the current through the capacitor. We're given the capacitance, which is equal to 50 microfarads. We're given the voltage across the capacitor, which is equal to the following sine function. So, if we're to find the current, we know that the fundamental equations that describe the behavior of capacitors is equal to, so the voltage V of t is equal to 1 over the capacitance C times the integral of the current I plus the constant K. So to get the current, we differentiate our voltage equation and then we get the current equation. So that would be, and if you want to write V of t, you can do that. So you can just do dt. So in our case, if we differentiate, well, we already differentiate. So we move over C to the left-hand side. So it move over C. So we get C times V of t. We would differentiate the right-hand side. This goes to 0. So we're left with I of t over this side. And we're left with C times V of t over here. And because we differentiate that, we keep the differentiation with respect to t. So we can then go ahead and say I of t is equal to, we keep the coefficient of our voltage, given voltage. We then multiply that coefficient by our 200 inside of our sine function, 200. And we know we keep the 50 microfarads, -6. Let's just do that, 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 and that. We know when we differentiate a sine function, we get a cosine function. So that would be cosine. Nothing in the sine changes, or nothing in our cosine changes. So that would equal to that. And we know the final answer after we multiply everything out. We would then get cosine 200t for our current through our capacitor. So this was a simple problem, not much effort. We just have to know the fundamental equation of our capacitors, are the fundamental equations that describe the behavior of our capacitor. So I'll see you in the next one. Bye.